Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, step 2, step 3, and your challenge is to predict the number of, well, what are these? Lollipops, swirly candy lollipop heads in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number in any step at all? That's the challenge. If you'd like to accept it, pause the video and see how far you can get with this one. All right, so, just visually, what I notice first is that these seem to be squares that get big pretty rapidly. So my first guess is this is going to be a quadratic pattern, but something pretty big. Um, let's see, we've got a 1 by 1 square here, and then it jumps up to 3 by 3, and then this is, yeah, 5 by 5. So it looks like the sides go 1, 3, 5. So I'm guessing this would be a 7 by 7 square. So we'd have 49 of these lollipop heads in there. So my prediction for step 4 is 49. But how about step 43? That's a little trickier, and we can approach this in a number of ways. Um, I guess, one way to think about this is to determine how big the sides are. I mean, that's how we found step 7, right? So we've got this pattern of 1, 3, 5, 7. What is that pattern? What's going on there? Well, I notice it's changing by 2. So, if we were analyzing this like we usually analyze our numbers, here's step 1, 2, 3, 4. And now instead of the number, I'm just going to use the side. We'd have 1, 3, 5, 7. If we took the differences there, we'd find a difference of 2 between each step. And that would indicate that the length of the side is increasing at a linear rate. So this is a linear pattern for the length of the side, and we could use that y equals mx plus b to get the side length. So our m is going to be our difference here. So this is y equals 2x, and then plus b, we'd go back to step 1 and figure it out. If I put in y equals 2 times 1 here, I'd get 2. That's 1 too many. I'd have to subtract 1 to get to 1. So y equals 2x minus 1. This is not the equation for this pattern. It's the equation for the side length. To get the number of lollipop heads, I would have to take this and square it. So I think our equation is y equals 2x minus 1 squared. You could FOIL that out. I think I will. Let's see, that's 4x squared minus 4x plus 1. This equation might be an easier form than this one, but they should both come out to be the same thing. Now, when we calculate the number for step 43, we should get, well, let's see, 1849 times 4 would be 7396. Yeah, and a minus 4x, 4 times 43 is 172. So minus 172 plus 1, and all of that's going to add up to 7225. So that's what I think it is for step 43. Let's take a look at using this, though. This might be an easier way to do it. If I plug in 43 for x here, multiply that by 2, I get 86. Minus 1 is 85. So I would just have to plug in 85 squared on my calculator. And lo and behold, that is 7225. So it looks like we must have done the foiling correctly. If you wanted to analyze the numbers here as we usually do, what it should tell us, if we've done all this right, is that our coefficient of our x squared term is 4. So I should get a difference of the differences of 8. So let's just double check that. 1, 2, 3, 4. There's my step numbers, and I've got 1, 9, 25, and 49. And let's see, that's 8, and this is 16, and this is 24. And I subtract again. 16 minus 8 is 8. 24 minus 16 is 8. And yeah, there's my difference of the differences. You divide that by 2 to get the coefficient. That matches the 4x we've got here. So checks out all the way around. So I think that was a pretty tough one. How did it go for you? Did you see this pattern of the side links and get step 4? Were you able to go beyond that and come up with an equation? Let me know. Thanks, everybody.